In this module, I'll go through the steps to build a hardware-based video controller. I'll also introduce the basic concept of stream interfaces. But before I get started, I want to talk a little bit about computer displays or monitors in general. The computer displays are arranged in two-dimensional grids of picture elements, or what we refer to as pixels. And generally, we have every display has sort of a resolution. And for example, the resolution here I'm showing is actually 640 by 480. The resolution is composed of two numbers, and these two numbers tells me how many rows I have and how many columns. Specifically, the first number, which is 640, tells me the width of that particular screen. Okay, so what it tells me is you have 1, 2, 3, 4, all the way to 639. From 0 to 639, 640 pixels or columns, which is the width. And it also tells me the height of this particular screen resolution is 480. That means you have 1, 2, 3, all the way to line 479, so 480 of them. Generally speaking, a row is referred to as a line, and all of the lines together combined, basically the whole screen, is usually called a frame. And these are just typical used nomenclatures for computer screens. So one other comment is, you might have seen it already, or you might know it already, that pixel 0, 0 is usually specified here. It's not like what we do in math in terms of x and y. So our x direction is here, basically, and our y direction goes downwards. And our pixel, or 0, 0 is in here, and the maximum pixel is here. Usually the largest pixel number is usually here. Okay, so what does a pixel by itself contains? Well, a pixel contains information about color. And specifically, it usually contains three different values. One for the red, one for the green, one for the blue, or what we refer to as RGB. And depending on the monitors, depending on the screen resolution, the hardware you might have different number of bits for each one of the colors. Generally speaking, a computer monitor will have 1 byte per color. So you will have 8 bits for the red, 8 bits for the green, for the RGB, and it's like in the blue. So if you think about it, it's 2 to the power 8 plus 8 plus 8, which is 2 to the power 3 times 8 is actually 24. So 2 to the power 24, it's about 16 millions, okay, 16 millions. So you have 16 million colors if you use 3 bytes. Each byte is dedicated to one of the colors. However, this will require a lot of memory, and since we are dealing with an embedded systems and we're building it on an FPGA, and because we're building it and we will build that particular controller on the Nexus 4, we were going to restrict ourselves to 4 bits for each one of the colors, so half a byte basically. So we're going to have 1 for the 2 to the power 4 plus 4 plus 4, and that will give me about 4,096 colors. So that's actually more than enough for our purposes. And the reason why we're restricting ourselves to 4 is because the hardware on the Nexus board, or even the Basis board, if you're actually using that, basically allows you to use that. However, in our codes, we're gonna make sure that these are parameterized so that if you're using a different board, you can easily modify it so that you can use the whole byte. Okay, so now we know that the screen is composed of two-dimensional grid of pixels, and that each pixel contains information of 3 different colors, and the number of bits per pixel or per color can be a little bit different. So one more thing that we actually need to think about is the following. So a pixel value can be retained on the display for a very short period of time. So it has to be refreshed very constantly. So in order for you to actually, let's assume that you're displaying some sort of a color in here. In order for you to continuously display it on the screen, you need to continuously refresh it and give that screen that particular value so that it actually stays on the screen. And when we're dealing with a screen, if we have that many pixels, we're not going to send the values of the pixels all together all at the same time, at least not using the protocol we're going to be building or the hardware we're going to be building. We're going to just send it serially. And as it turns out, that the hardware we're going to be building, it will be sending this pixel value followed by this pixel value followed by this pixel value followed by this pixel value and so forth. We're going to send it line by line and a frame by frame, and we're going to keep doing it, keep doing it, keep doing it. And this is what you see on this particular diagram here. So what you see in here is, like for line 0, for example, I'm sending from pixel 0, 0 all the way to the pixel 639. And that's basically for this line. And then we do line 1, and then we do line 2, and so forth. And all the way till we get the whole frame, which is a bunch of lines. And that's basically the whole frame, basically the whole screen. And in order for you to maintain the values of the pixels on the screen, and so that for our eyes to actually see it without flickering, you need to refresh that screen or that frame using 60 hertz basically. Which means that this particular frame has to be basically refreshed every 1/60 seconds basically. So every second you're actually sending this 60 times. You're refreshing it 60 times. And the pixel data again are basically sent in serially. So the difficult part about building a video controller is this synchronization here, and that's our ultimate goal, is to build some sort of a synchronizer that you'll send it like, okay, if you're here, this is the pixel value, and then you move to the next pixel, and then you move to the next pixel, and it has to be at a very, very specific rate so that you can achieve this particular frequency in here, or basically the refresh rate. Okay, so the control that we're building will be based on the VGA, which stands for Video Graphics Array, and it was introduced in the 80s, in the 1980s, with IBM's PS2 PCs. So the term VGA is not really precisely defined, and it might refer to one of three things. The VGA port itself, which is just a connector of 15 pin, and this is a picture of that port. You probably have seen it. For some reason, this particular port have lived from the 80s till recent years. You still probably have a monitor or a screen or even a TV that actually supports this. I think in the past couple of years or so, I started seeing monitors without the VGA, but anyway, it's still widely supported. So if you want to take a look at what these pins mean, I would refer you to this particular Wikipedia page, which actually talks a lot about the VGA. But anyway, what we really care about is actually the pin number 1, pin number 2, and pin number 3, okay, because they actually specify the red, the green, the blue, because we're going to specify all three of them at the same time serially. So we're going to be sending that. And also, we'll in our synchronizer, we'll be focusing on pin number 13 and 14. You don't have to remember the pins. All you need to remember or know is we're going to be generating the red, green, and blue in the H sync and the V sync, okay, which is the horizontal sync and the vertical sync. The other pins are important, but in our simplified VGA controller, we're just going to be basically generating these particular signals. Going back to the VGA, so the VGA is not precisely defined, so it might refer to this particular port, or actually the interface itself, like the way we're going to generate these H sync, V sync, and all of the timing and the 60 hertz and something. It also sometimes refers to the resolution of 640 by 480. As it turns out, this is actually a very common resolution, and it's usually called the VGA resolution. So if I'm saying VGA, generally speaking, I probably would be referring to the interface, but I'll specify something else, like I'll specify if I talk about the resolution or actually the port itself. Okay.